Now we will see radix to FFT algorithm. There are two types of FFT algorithm. First one is decimation in time, that is DIT FFT algorithm, and decimation in frequency, that is DRF radix FFT algorithm. First we will see decimation in time DIT FFT algorithm. So in DIT algorithm, the time domain sequence x of n is decimated and smaller point DFT are performed. The result of smaller point DFT are combined to get the result of n point DFT. In DIT FFT algorithm, the time domain sequence is decimated into 2-point sequence. For each 2-point sequence, the 2-point DFT is computed and the result of the 2-point DFT are used to compute 4-point DFT, and the result of 4-point DFT are used to compute 8-point DFT, and so on. So it is 4-point DIT FFT algorithm. So how many stages we have to draw for the 4-point DFT? So here n is equal to how much? 4 samples. 4-point DFT. For that it is equal to 2 raised to m. M is equal to what? 2. So we have to draw up to 2 stages. This one is a first stage, and from here to here it is the second stage. This is first stage of DIT FFT algorithm, and this is second stage of DIT FFT algorithm. From the output of 2-point DFT, we have to find the output of 4-point DFT, and output of 4-point DFT we have to find 8-point DFT, and so on. So now this is the flow graph of DIT FFT algorithm. So here how to represent input and output. So output can be represented in the sequence x of 0, x of 1, x of 2 and x of 3. And input is exactly the reverse bit of the output. This 0 can be represented in the bit form 0 0. So 0 0 reverse bit is also 0 0. So it is what? First input is x of 0. Now x of 1 is in the bit, we can write 0 1. Reverse bit is what? 1 0, that is 2. So in here we can write x of 2 input, and 2 is represent 1 0. Its reverse bit is 0 1. So its value is 1. So it is x of 1. X of 3 in the binary form it is 1 1. So it is also reverse bit is 1 1 and it is a 3. So now fourth input will be a x of 3. So here we have given the output sequence and the input sequence. Output sequence in the sequence form 0 1 2 3 of x of k, and input is exactly the reverse bit of the output. So our input is x of 0, x of 2, x of 1 and x of 3 for the 4-point DIT FFT algorithm. So now we have to calculate what is the value of this total factor W of 04 and W of 14. For that we have to apply e raised to minus j theta is equal to cos theta minus j sin theta formula. So now first value of total factor 04. Value of kn is 0. We can write total factor value is minus j 2 pi divided by number of samples are 4. So 4, and kn value is 0. So it is what? E raised to 0. So value is 1. So here omega 04 value is 1. Omega 04 value is 1. Omega 04 value is 1. Now second term is omega kn is 1 and 4. E raised to minus j 2 pi divided by 4, kn value is 1. So its value is e raised to minus j pi by 2. So we can write this equation as cos pi by 2 minus j sin pi by 2. So its value is minus j. So instead of this omega 14 we have to put minus j value. Now calculation of first stage. Stage 1 calculation. Here output A0 of stage 1 is, we can write A0 is equal to x of 0 plus x of 2. A1 is x of 0 minus x of 2. B0 x of 1 plus x of 3, and then B1 x of 1 minus x of 3. Now what is output of second stage? stage 2 calculation. So final output, that is x of 0 equal to a0 plus b0, x of 1 equal to a1 minus j b1, or we can write this equation as a1 plus omega 1 for b1. Then x of 2 equal to a0 minus 0 for b0, or a0 minus b0. X of 3 is equal to a1 plus omega 1 4 into b1 into minus 1, or we can write a1 plus j b1. So it is the calculation of first stage and second stage of DIT FFT algorithm.